I am thankful to Dr. Mustafa Mesbah, working at Electrical and Computer Engineering Department in Sultan Qaboos University as Associate Professor, for providing the PowerPoint slides for these lectures. I have slightly modified the original slides. Again, thank you very much, Dr. Mustafa Misbah. Assalamu alaikum wa rahmatullahi wa barakatuh. Initially, I decided to make the special cases in one lecture, but now I am feeling that it is better to split it into two cases or two lectures. So to the first one I gave the lecture 6_3A, and the second lecture will be 6_3B. So in this part of the lecture we will be considering the special case in which a zero appears in the first column of the Routh-Hurwitz table. So here uh, we see that if there is a zero in the first column, we are faced with the division by zero, because this zero will be coming in the denominator. Whenever we do the example, it will become more clear. In this case, we replace the zero by a small positive number epsilon, and then we continue for the computations, and we decide the next number will be positive or negative. So here we take this example. So to determine the stability of the system, this means we need to confirm the zeros of this polynomial are in the left half S-plane. And if there will be a zero of this polynomial, which is the characteristic polynomial to what we say pole of the system in the right half plane, the system will be unstable. So the root table on the next slide we are going to discuss. So here the polynomial I just copied from the previous page. So here s to the power 5, so now this is 1, we leave this one, then 3, then we leave this and 5, and similarly we write the second row. So as we learn how to display the system row number 2, so here it will be that we copy the first these two element here, and then these two element, and divide by 2. So here we are getting 0. So we will discuss in the next step. Uh, so we will replace this 0 by epsilon. So here we see we are getting a number, so no need to replace it. And the next one 0, but this 0 is not in the first, not a first element of the row. So if in the first column we get something 0, we will replace that by epsilon. And why it is necessary? Here we see that if there could be a 0, then divide by 0 cannot exist. So to avoid that problem, we replace it by a small positive number epsilon, and epsilon is tends to 0. Now the equation can be written in this particular format. So we will discuss this in detail in the next slide once we determine the elements over here. So the rest of them are as usual like this one and this one as we did in the previous example. So in the similar way we can do this. Similarly, we will calculate the next element, and this element will become 0 because here and here we have 0. So just try by your own calculation, you will get over here 0. Similarly, you will get here 0. And this is easy to determine. Do this on the paper, you will find it how to do it. So now we have to find out the third one over here, like it as 0, that what will be the value. So here when we do the calculations, we will obtain 3. The rest of them are 0. So now to determine the stability of the system, or to find the number of poles in the right half S-plane, we have to look for the sign change in this column. So summary of this table is given on the next slide. So on this slide, from the previous slide, we have written like all the element over here. Now the first thing, like these are the elements. So here this sign is positive, this is positive, and we consider that epsilon is a small positive number. So here we see that whenever epsilon tends to 0, so the first element will be 6 and the second will be minus 7 divided by 0. So this very small number. So this means this number will become a negative number. So here is a sign change. So because of this sign change, we can see that it is negative. Now we look to the second one. Whenever epsilon is 0, so this element becomes 0, this element becomes 0, this element becomes 0. So it will be minus 49 divided by minus 14. So minus will cancel with minus, like this one. Whenever epsilon tends to 0, like if limit epsilon tends to 0, here we will get minus 49 upon minus 14. So definitely this minus and this minus cancel. So we will get here plus. So here is a plus sign, and of course for 3 we have plus sign. Here again the similar thing, like limit epsilon tends to 0. If we check over here, so this one will be approaching to negative infinity. So if it is approaching to negative infinity, this means that it is a negative number over here. So this is why here we have negative. So now if we look to this, from positive it become negative, and from negative it become positive. So the sign has been changed twice. This means there will be 2 poles in the right half S-plane. So the rest of the poles will be on the left half S-plane. There is another way to solve such type of problem, and in this problem what we do, that suppose our polynomial initially is in this format. So what we do, we take s is equal to 1 over d as in this one, and then d of s polynomial can be replaced by this. So the s has been replaced by 1 over d. So the polynomial will become in this format, and a little bit simplification of the equation will lead to this format of the polynomial will be equal to 0. So now if we look to this equation, this means the coefficients are in the reverse order. Coefficients are in the reverse order over here. So because of this, instead of solving the previous equation, we look to this polynomial, we look to this polynomial, and then we find out the uh, Routh-Hurwitz table. But the negative thing is that in some cases, even this polynomial will give us a zero in the first column of the table, but in some cases it goes without any difficulties. So let us consider another example. Determine the stability of the closed loop system function, which is given by this polynomial. And again we see that we replace the coefficient, like we reverse the coefficient as we learned on the previous slide, that this 3 will come here, and then you see just we reverse the coefficients. This first coefficient will become the last one, and the last is the first one, so we wrote the coefficient in the reverse order. So as we were replacing d, so this type of equation we are looking for. So in this one, when we generate the table, so no zero is here, no zero is appearing, but there is a sign change. Here it is plus sign, then it become minus, and then it is plus. This means there are two sign changes over here. So this means two poles are in the right half S plane. So one thing you should remember, that when we reverse the coefficients of a polynomial, the number of zeros in the right half plane for both of them will remain same, though their location will be changed, but the number of poles on the right half S plane, or number of zeros of the polynomial on the right half S plane of this polynomial and this polynomial will be same, though their coefficients are in the reverse order. So this means the result of this one and this one is same. So these two methods can be used, but in some cases even you reverse the coefficients, it may generate over here 0. So it is better to know both of the techniques.